Hello and welcome back to Minecraft. Today we are going over what I've built, which is my 4-bit wolf drive. This is based off the design by SethBling. I believe he called it Lupine Read-Only Memory. However, this adds support, as you can see right here. It adds support for read-write memory, which is very critical in designing any sort of computer system, is having a read-write memory and not only read-only memory. This is a fun little project I went on. I wanted to see how easy it would be, and it turned out to be a lot more simple than I thought. So let's just go over this right now. Currently, there is no data in the hard drive, as you can see right here. This is the critical stack. In fact, let me put a sign here. Main memory. This is everything that's being written and read out to the outputs. This is where everything is stored. It's in the stack, which you can see in SethBling's video. If you haven't watched it, I strongly suggest you would. I'll leave a link to that in the description, but it basically goes in here, and it's caught in here, and it just sits in here. It sits the data in here until the data is popped out, which I'll go over later, which has changed a bit. So that's just our main memory where it's stored. This is where we store our wolves. Can I place this sign on top of glass? Yes, I can. Wolf storage. Because of how this works, I need to have the wolf or the true bits separate from the false bits. So this is where the wolves are stored. Unfortunately, the data cannot come prepackaged in the world download because the fact that entities will get out of the minecarts they're in when the world reloads, which really sucks. But you get what you get. So I created this little design over here, which is just a simple couple of dispensers, a couple of minecarts, and some wolf eggs. Push the button, out pops a wolf in a minecart, and it goes in this stack. Right now, it's limited to a capacity of 4 bits without overflowing, which is okay. I mean, it's extendable, and you can basically extend it as high up to block limit as you wanted without changing any of the redstone wiring. That's the beauty of this. You just have to extend the rails up farther, and it might damage the wolves a little bit more on the way down, but that's a small price to pay for really high, really large data storage. This is not persistent. As I said, the entities will get out of their minecarts, but it does have the main advantage is that it doesn't use a lot of redstone to accomplish the tasks, which means it will not slow down a server that much. I've seen other designs that use emulations of DDRAM, but those really slow down a server or your game because there's so many redstone calculations that go into that. This is, however, very simple. It relies on minecarts, which are much faster and more reliable. Well, they're not faster exactly than redstone, but it's a lot more reliable than redstone in that it can pretty much be guaranteed that the minecart rails will do what they need to do eventually, whereas with redstone there are some things that can mess it up. I haven't found a way to corrupt the data at all yet, so next thing I want to do is I want to get some more minecarts, and I want to just create the initial stack of memory. I'd strongly suggest you just use 4 false bits, and in fact, you can even I could even, I guess, prepackage these bits. But I want 4 false bits as the initial memory stack, just so that's my data capacity. You can't have it. This makes it so there can't be any more or any less than 4 bits in the stack at a time, which is what we need. Now we got to load up the false bit stack, which I'm just going to put 1 in here because it needs to be there if we're going to try and set the initial bit to false. Each one of these stacks always needs to have something in it. So in fact, I'm going to dispense a fifth wolf out. If they don't have one in it, there could be problems when you're trying to set a bit, and you could lose data out of the stack, which is never good. So let's just go into what happens now. So the first thing I want to do is just show that the standard stack just pops just like in SethBling's video. So you pop current bit, stack goes around, comes up to the top. Pretty simple. Some minecart mechanics have changed since SethBling made his video, so if you notice, these minecarts get a little bit turned as they leave the rails. That's why I have to have the glass surrounding it, or else they will turn off the rails and they'll go all over the place. So that's okay. It doesn't make too big of a difference to the design. It just means you have to have glass surrounding it. So as you can see, all the bits pop just fine. Our output is continuously off because we obviously don't have any true bits in the stack. Now let's try setting this next bit to false. So notice we've set the next bit down, so that's now down, so we don't have to worry about that. Now we have our value to false, so when we pop the next bit, this comes out, it goes through this, at which point it pops the new false bit to the top of the stack. It doesn't check to see if the new value is equivalent to the set value. It just literally pops it out and sets it back in. While that might increase performance, I guess if I check the value of the minecart to see if it's the same and just send it to the top of the stack, It's not something I'm really worried about because it is very fast as it is using these powered minecart rails. I guess that's one disadvantage to this design is that it uses a lot of powered rails, but I think it's worth it. And if you're really doing this in a creative build for something, I don't see it being too useful in adventure maps or anything unless it's in a multiplayer setting. Simply because of the fact, like I said, it's not reset. I mean, it's not. You can't. It's not persistent across loads until they fix the whole entities and minecarts. So that just shows we can set a false bit. Now let's try and set a true bit. So pop the current bit, which pops this one off the stack, and then it's going to be replaced by a cart with a wolf, which is of course a true bit. If you don't understand that, look at SethBling's video again. He explains how that works, and it's using the exact same design here. I mean, you see the pressure plates right under there. Don't know how easy it is to see, but it's there, and so it just pops just like you expect it to, which is good. And the next thing I want to talk about is some of the wiring behind it. But for now, let's add a second true bit. Let's add a false bit in there too, and another true bit. So now we should have true, true, false, true. And if you notice, they're all going in unison. They can go at a time. And if you notice, we have 3. There's a 4th bit. So we got true, true, false, true, like we set. And it's exactly how we'd expect it to be. Let's jump into the wiring here and just explain how it is. Oh, notice the output is now on because the bottom wolf is true. One thing about the design, just to note, it's the same in SethBling's version, is that if I pop to the next bit here, let's not set anything. Pop to the next bit, the output stays on. The output does not flicker at all. So that's a good thing and a bad thing. It means that consecutive true bits will not change the output, which could be good if you're using this in like a display setting where you don't want pixels to constantly be refreshing. But it's a bad thing in that if you do it wrong, this output would be, if you need a pulse detector, this is not going to work as a pulse variation of a hard drive. So it has its advantage and disadvantage. Take that as you will. Let's jump into some of the wiring that I added. I'm not going to even touch this stuff right here other than saying that this just wires out to the output as you would expect. Wires back into the redstone lamp for the output, and this pop next bit goes right over here to this piston over here, just like in SethBling's video. I mean, there isn't any change here, so that's a good thing. I mean, it's simple to follow, and if you don't understand it, then just watch his video. He explains it much, much better than I can. So now we're going to go into what's changed, and that's over here in our minecart rails to start with. So this is what's changed. Right now, we have this, which goes, this is when the set bit's off. It just literally continues the loop. There's no extra processing done, which makes it very fast for just reading the data. You should almost never run out of data if you're just doing reading. So it's very, very good. It means you can read almost as fast as you can trigger a redstone pulse. I wouldn't worry about that too much. But what this has changed is we now have some torches down here which do some stuff. This is leading directly from our set bit. So if we have it set to set, if you notice what happens is it flicks this minecart rail right here instead of going around up. It goes through this section, which we'll cover later, but that's being done via a simple torch under here, powered by this torch, which inverts this signal. And when that torch is on, it goes that way, and when the torch is off, if we come over here, turn the torch off, notice the torch is off, it goes this way. The second torch here was necessary at one point. I don't believe it is anymore. It was simply because of an earlier design. I had this trying to go up, and that was just a nightmare. So now let's go into our cart return system right here, as I was talking about. So we got this. This is our cart return system where after we set a bit, which we'll go over later because it's the most complex part, it comes down this track and into here. So what happens is, as a bit's being popped from here, after we determine we need to set this bit, it just simply goes up, it falls down in, and goes through. It's very simple. Same thing on both sides, although the wolf setting does take longer. I mean, obviously there's a lot more track to get it across. It's about comparable to 1 second of delay from when you push the button and when the bit's going to get to the top of the stack. I mean, it's about that. I mean, it's a little bit more. I mean, it all depends on a couple of redstone factors, but I'd say it's about a second you can rely upon it. So I'm going to call this 1 second latency hard drive. Or not really hard drive, but wolf drive. You know what I mean. So now we're getting into the meat and potatoes of this thing, which is the detection system. This is our minecart sorter right here. Wolves, when there's a minecart with a wolf in it, it'll trigger this pressure plate here as it comes down, and it'll push, this piston will push out, and it will send the wolf carts down this track, which means it'll reset over to here. This also means that wolves reset faster than empty minecarts, because empty minecarts have to go a little bit farther, which is a good thing, I guess. I mean, wolves set longer, but they reset faster, so it all comes down to really a little bit extra timing, and it's not going to make too big of a difference in any effective setup, but just something good to know. And empty minecarts will just follow their track along to here. which means that this sorter works perfectly well. If you notice, I have a detector rail here. This is how we determine when to set the bit. So as the minecart, here we go, let's turn on the set, and let's follow this. As the minecart goes across, it sets that, and if you notice, the wolf goes properly to there, and new wolf comes down. But this comes up to here, where it just goes vertically up to this section right here. This is how we know when the detector rail is being pushed. I couldn't find a better way of doing this, so I just used a redstone torch with a repeater and a block. It should work fine in most situations, and that goes into 2 gates. This goes into not exactly a NAND gate. I think it may be a NAND gate. I'm not sure the name of it, but it sets this is the bit value here, by the way, coming up, and right now it's set to true. So if the value is true, this will be off, and this AND gate will never fire. Alright, so even when this triggers on, this will never fire because the value is set to true, which means the false line will never reset. And it goes through an AND gate after knotting the value over here, and it basically does the same thing over here, except it just goes directly into an AND gate, in which case when we get the detector rail pushed, it'll come down here to eat this line and pop the next bit out of the stack using this piston. So it's a very simple concept, really. I mean, I haven't run into any issues with it. The hardest part, really, for this was the sorter. I mean, this sorter was a pain to build because SethBling had a video idea where you could put it through a T, but unfortunately that got patched in one of the snapshots, which really sucks. I mean, it made my life a lot harder, but in the end, I think it turned out okay, and this is a little bit more efficient than his sorter, I believe. And obviously, same thing comes down for this false stack, which we have we have 4 false values right now, and I believe, is this all true? No, I think we have 1 false value over here, and we have 1 extra wolf, or 2 extra wolves, excuse me, over here. We got our bit value set to true, it's not set anything, pop the next bit, false, pop the next bit, true, true again, true, and then of course we got false. The bit reading takes a little bit of time, but that's to be expected as pressure plates don't light up immediately, and that's nothing I can control. I mean, it goes through 1 repeater down here, but I wouldn't expect that repeater to make that big of a difference in any practical application. I don't see this having too much of a use in a creative or survival mode, even though it's more of a proof of concept to see if it was possible to create or rewrite a lupine memory system, which it is, but it's I call it a RAM type system where it's not constant. It's not a saved disk. It's use it once and then it destroys itself after. So let's just show what happens when we reload, and we'll just look over here. See these 2 wolves, save and quit, single player, launch my world, and the wolves have left the hard drive. So that kind of breaks stuff, but you know, whatever. It appears these wolves actually decided to stay in, so it's definitely not consistent. And as you notice, the signs also remove. So yeah, the wolves can kind of mess this up, and I also want to let you guys know that many wolves were harmed in the making of this video. I think I may actually still have a couple aggroed wolves down here. No, I don't. I guess I killed them all off. But yeah, there was a lot of testing that was done involved in this, and it ended up with a lot of wolves getting mad at me. But there isn't too much you can do. And if you're a fan of PETA, well, sorry, but I don't really care. I hope you guys did enjoy this video. Next time, I guess we'll be covering my automatic melon farm here, which will give you a little bit of a preview of. But other than that, guys, this video is about over. I'm AngerBeast, and I'm signing out, and I'll catch you guys in my next video.